Hello. In this tutorial, you will learn how to make springs whose ends are closed and ground. We have 11 coils in the spring whose free length is 1.812 inches. The outer diameter is 0.593 and the wire diameter or the coil diameter is 0.093 inches. So here I have a part file opened, and remember this part file is in inches. You want to work in inches while you follow this tutorial. So here I just moved the curved command on my part file under my ribbon. So under the curve tab, you have the Helix. So you want to click on Helix. If you cannot find Helix, you can as well search for Helix in your find command. So let's click on Helix. So this way we have a helix at the origin. So here we need to change the size, whose law type is constant, but we want to change this value to the one that we are using, which is 0.593. But then what we really need is the mean diameter, and to get this mean diameter we need to subtract 0.093 inches from 0.593. So we will do, so I just accidentally moved my helix, so I'm going to place it back at center by clicking on the origin. So I need 0.593 minus subtracting 0.593 with 0.093. Let me check if that's right. Yes, that's right. 0.593 subtracted with 0.093. The pitch is determined by 1.812 divided by 11 turns. So that's my pitch, and my start limit is 0 and my end limit is 1.812. all right. So with that, I'm gonna click OK, and we have our helix applied. Now, what we really need is ground, so it needs to be able to sit flat. So to close, we will be adding an arc here. We can do the same operation by using bridge curves, but in this tutorial, we'll be following a simple command. So what we need at this point is we need to create a curve here, right? We need to create an arc. So I will quickly say sketch in task environment, and this is on path. I'm gonna change this to on plane. We want this to be on plane method on inferred, and this is on inferred as well, so it's simpler like that, and it's already selected the right plane for me, and I'm so now I will create an arc at this point. So what I will do is I will click on the arc command, and then we want to start an arc from the end here, and we want it to be tangential. So if you don't get it tangential in the beginning, then all you got to do is create tangential constraint later. So I'm gonna ensure it's tangential. If you cannot make it tangential, or if you find it difficult, just leave it out like this, and then you can always get back and you can say more geometric constraint, and you can hit tangential. You can say that's tangential to that guy, and that's how you make it tangential. I also want to, so we need this helix and this grounded part of the spring finally to have the same mean diameter. So I will constrain the center to the origin. In that way it's automatically going to be the same diameter. All right, so that does the trick, and I can making the spring as big as we want or as small as we want. I will fix this at 0.25, let's say, so that we have something here. 0.25. I just want to ensure like my constraints to be fully constrained. So With that done, I'm gonna finish the sketch, and we have closed spring. Now we need both the ends closed, so I'm gonna create another arc on the top. So to do this, I will create an arc again, but well, before I do this, I will need to create a datum plane. And what I'll do now is I'm gonna keep this at invert, and I'm gonna select my datum plane on the bottom, and also select that point, and I want to ensure that's 100%. Okay, that's at the end. So I selected the end. You want to be careful that you select the end. Once you have selected the end, click OK. So what we have now is we have a plane. We have a plane whose subtype is point and plane. So we created a plane using a point and offsetting it from a plane that already existed. So the reason we do this is ultimately, if you want to compress the spring, you can just change the length of the spring, length of the helix, and everything else changes automatically when you want to compress the spring, because what we are designing here is a free length. So 1.812 inches is free length. So we are designing free length. So now on this end, we will have to draw another arc. So now what we want to do is we want to create another arc on the top here. So to do that, click on arc again and select the end like before and drop a random arc. And then what we want to do is more geometric constraints. Make these two tangential. And then we want this origin to be at the center, right? So we want to ensure these two centers are aligned. They are aligned. In our case, if not, we can always do. So let's just do coincident constraint. That center of that arc, and we can also like select that origin, arc origin. So I'm selecting the center of the other arc just so that those two are in line. I did not move. So again, let's select the center of this arc and select the center of that arc. So those two centers are aligned now. Now what we'll do is we are gonna extend this. I'm gonna leave it there, and I'm gonna call the dimension between that point and that origin. I'm gonna call that as 0.25. That's okay. So I'm gonna just make it similar to what we had before that. So we want both these ends closed, right? Okay. So now what we do is, now we want to create a circular cross section and sweep it all along this curve. And remember, we made these tangential, so these curves are smoothly transitioning. So let's create sketch, but this time instead of a sketch on path, we will be working on sketch on, instead of sketch on plane, we will be working on sketch on path. So now select the path. Let's select that path. All right, we want to select the end there and then click OK. Ensure it's at 100% or 0% so that we are at the end. We want to be at the end for sure. And now we are already on a sketch, so we can start drawing that. We will draw a circle because this is a circular cross section. The spring is a circular spring, and we will draw a spring with diameter of 0.093. That was our wire diameter or the coil diameter. So that's what's going to be drawn here. And now we will extend this. We will draw this completely. Go around a circle. So let's do this. So we will do surface, and you can either do surface or it's already, or you can just go home and you will see under more, you will see variation, you will see sweep along guide. So we want to select sweep along guide, select the curve and select the guide. You want to select multiple guides. So first select that, select the helix, then select the final curve and then click OK. So the boolean is none, which is fine because it's all single, it's all the same curve here. So now these springs need to be grounded. So we need to make them flat so that they can sit on something, a surface. So to do that, what we need to do is we will need to trim the spring at the end. So we select the body, select the face, and that'll be the plane. If the wrong side is selected, you just need to reverse the direction. Click OK. Do the same for the other end. So we do trim body. So that's the body. And select face or plane. We want, that's not the plane I want to select that one, right? So again, choose the right direction of the vector, click OK. So here we have spring that's whose ends are closed and grounded, just like this, right? So now if you need to further, let's just hide these datum planes so that we can see what's happening here. And I'm gonna hide the sketch, I'm gonna hide that sketch too, I'm gonna keep the helix, that's okay. So we have the helix, we have the spring. So now if I want to change the length of the spring, right, like I want to create a compressed spring. So let's go back to helix and let's say I want to compress the spring. I want to compress it to, let's say I want to compress it to 1.7 inches. Okay, I want to compress it to 1.7 inches, and then I'm gonna make this 1.72 because the pitch changes as well, but the number of turns are the same, so I'm gonna keep that same. So you see, although I changed everything, although I changed my length of my spring, my datum plane accordingly moved because everything is linked, because I constrained when I created my datum plane at the other end here. When I created my datum plane at the other end, that one, I ensured that it was constrained to the end point of the helix. So ensure you constrain, you start the datum plane with the end point of the helix that you constructed. In that way, when you change the length of the spring to the new compressed length, or if you want to keep it at free length, the entire spring modifies correctly. That's it for this tutorial. Thank you. If you have any questions, please